Hello everyone, this is Varun Wadhwani. I'm a student of IIPS DAVV Indore. Here I'm going to solve a question which is calculate the value of the polynomial x cube minus 4x square plus 0.1x minus 0.5 for x equals to 4.011 using two approaches. First is straightforward determination and second is nested parenthesis method. Use floating point arithmetic with 4-digit matrixa. Find the relative error in the two methods. First, using straightforward determination, uh, we will solve the question or the equation in parts. First, we will find the value of x cube by substituting the value of x as 0.4011 even. The value of x cube is coming out to be 0.6449 e2. This is our equation number A. Then minus 4x square is coming out to be minus 0.6432 e2. This is equation number B. And 0.1x is coming out to be 0.4011 e0, which is our equation number C. And minus 0.5 in 4-digit floating point arithmetic is minus 0.5000 e0, which is our equation number T. Adding A and B, x cube minus 4x cube is coming out to be 0.1700 e0, which is our equation number 1. And adding C and D, we will get 0.1x minus 0.5, which is minus 0.0989 e0, which is equation number 2. Adding 1 and 2, the x cube minus 4x cube plus 0.4x minus 0.5, that is our equation. That is the value of our equation is coming out to be 0.7110 e minus 1. You can see the calculations. Now the second method, that is nested parenthesis method. The polynomial equation can be rewritten as in the form as you can see, minus 0.5 plus x times of 0.1 plus x times of minus 4 plus x. Solving the polynomial in parts from right end, we get minus 4 plus x. The value of minus 4 plus x is 0.1100 e minus 1. Call this equation A. Then the value of x minus 4 plus x times of minus 4 plus x is coming out to be 0.4412 e minus 1, equation number B. Then 0.1 plus equation number B is coming out to be 0.1441 e0, that is our equation number C. And x times of equation number C is coming out to be 0.5779 e0, that is our equation number D. Now minus 0.5 plus D is equals to 0.7790 e minus 1, which means the value of our polynomial is 0.7790 e minus 1. Now to find the relative error, we have to calculate the value of polynomial using 8-digit arithmetic. Again, solving the equation in parts, the value of x cube is in 8-digit arithmetic is 0.64529453 e2, calling it equation number A. The value of minus 4x square is coming out to be minus 0.64352484 e2, equation number B. 0.1x is coming out to be 0.4011 0000 e0, that is equation number C. And minus 0.5 is equals to minus 0.50000000 e0, that is our equation number D. Adding equation A and B, x cube minus 4x square is equals to 0.00176969e2. That is calling this equation as equation number 1. Adding C and D will give us 0.1x minus 0.5, that is equals to 0.0989 0000 e0, that is equation number 2. Adding 1 and 2, the value of our polynomial, after placing or substituting these corresponding values, we will get the value of polynomial as 0.78069 000 e minus 1, which is nearly equals to 0.7807 e minus 1. Now percentage error in method 1 will be 0.7807 minus 0.7110 divided by 0.7807 into 100, that is equals to 8.9%. And percentage error in method 2 is 0.7807 minus 0.7790 divided by 0.7807 into 100, that is equals to 0.2%. The B part of this question actually, develop an algorithm to find cube root of any number using bisection method. Let x is equal to cube root of n, where n is the number whose cube root is to be required. Cubing both sides, x cube is equals to n, that is f of x is equal to x cube minus n equals to 0. Bisection method to find root. First read x0, x1, e, where x0 and x1 are the two starting values which enclose the desired root, and e is the error allowed in the answer. Step 2, f of x0, store the value of f of x0 in y0, store the value of f of x1 in y1, initialize I with 0. If sine of y0 is equals to sine of y1, then begin. Write starting values unsuitable. Write x0, x1, y0, y1. Stop. And while x1 minus x0, uh, actually while a mod of x1 minus x0 divided by x1 is greater than e, do begin. Store the value of x0 plus x1 divided by 2 in x2, and the value of f of x2 in y2. Then increment I with 1, that is I plus 1. If sine of y0 is equal to sine of y2, then x0, then uh, uh, store the value of x2 into x0, else store the value of x2 in x1, and write solution converges to a root. Write number of iterations, that is I, and write x2 comma y2, and will stop. Thank you.